everyone. Welcome to this session. I'm just going to hide the controls. Today, I'm going to run a session called Speedrun SecretVault. And just to introduce myself quickly, I'm Steph Orpilla. I'm the head of developer relations at Nillion. And I'm excited for you all to kind of like understand SecretVault and start building with it during ETH Global Agentic. And just because I know you're all curious, we are giving away $5,000 in prizes for this hackathon. The first set of prizes is for best use of Nillion SecretVault. And there's a little star next to that prize because this workshop is all about Nillion SecretVault, and I'll get you up and running with Nillion SecretVault really fast so you can use it and integrate it into all of your projects for the hackathon. The other prize is a prize for building an agent framework integration. There's a $1,000 prize for the best framework integration, and that's for anyone who happens to create a library or a developer tool that makes it easier for other developers or users to use Nillion with an agent of your choice. So maybe that's Eliza, maybe that's something on OpenAI. Any type of AI agent framework integration could win that prize. So this one is kind of a wild card and it's more open-ended. And then the other prize, again, there's 4 of them for the best use of SecretVault, which I'll show you next. Oh, and you can scan this QR code here to learn more about the prizes and understand what you have to do to qualify. But now I want to talk about Nillion SecretVault. So SecretVault is a decentralized storage solution, and it's for keeping sensitive data secret. And it works by storing encrypted shares across a decentralized cluster of Nil DB nodes. The reason that SecretVault is so cool is that your data stays secure. So this is really great if you're building anything with your AI agents that's maybe using user data. So if your agent is storing user data somewhere, it should be stored in a place where user data is kept super secure. This could also be useful if your agents are in a swarm and they're talking to each other and they need to share data with one another, but they don't want to leak that data out because that would create just like a leak where someone else could take in that data and understand what the swarm is doing, and then your product is not as useful potentially. So with Nillion SecretVault, you encrypt data, and when you encrypt the data, you split it into different shares, and each of those shares is stored in a different Nillion DB node so that any node doesn't see the encrypted data, they just see a share that's meaningless. So that's how we're using SecretVault to secure data. One of my favorite things about using SecretVault is it's very easy, in my opinion, to integrate because the way you access and interact with SecretVault is through easy-to-use APIs. Before Web3, I was in a Web2 development background, and I was always using APIs. So when I came into Web3 and I had to get used to more complex ways of reading and writing, either through clients or through anything else, I found myself missing APIs a lot because it felt so easy to understand how to interact with something. And SecretVault is cool because you can use APIs to create schemas and then read and write data to these schema collections. So that storing and retrieving data feels very familiar and easy. And then the last reason I really like building with SecretVault is because we provide a couple powerful libraries that you can use out of the box. The first library is called NilQL, that's Nil Query Language, and that's for the encryption and decryption of any of that private data that you want to store in SecretVault. The second library is called Nillion SecretVault Wrappers, that's Nillion SecretVault Wrappers, and that's basically a JavaScript NPM package that does a lot of the API calling for you. Because you're writing to multiple nodes, if you were using the APIs directly, you would have to use n number of APIs, 1 per node. But if you use the wrapper library, it simplifies that. So you just tell the library, oh, I want this node, and that node, these 3 node URLs, and then it handles all of the API calls for you. So that's a little bit about SecretVault. And then the other thing to talk about is NilQL. That was that encryption and decryption secret data library that I was telling you about before. So this is an example of a record that I might want to store inside of SecretVault. It looks like a JSON data payload, but there's a couple things to note. There are these allot markers within the data, and anywhere that allot is will signal to NilQL, the encryption library, that that value needs to be encrypted. So the first value that I want to encrypt is name that's allotted. So my name will be encrypted in the resulting data. I also want to encrypt the number of years that I've been in Web3. So I also have an allot property there showing this number should be encrypted before it's stored. For rating of the product, imagine that's something that's just in a survey. That's not sensitive to my application, so I don't need to allot that. That can just be stored in plain text. And when NilQL runs on this record, when you encrypt it with the library, this is what the resulting data could look like. So I have 3 different sets of data, and each of these sets has those encrypted properties. So you can see name and years in Web3 in all 3 of these is written with a share. And the shares are different between nodes. So the first node will receive this payload with different shares than the second node, with different shares than the third node. So if someone were to crack the security of one node, they would still have no idea what the name or the number of years in Web3 would be for this record because it's encrypted with a share, and the share is completely meaningless. But when you use NilQL to decrypt or to recombine this record, it will give you this back. So you'll be able to see the name, the years in Web3, and the rating of the product in plain text because it's recombining those shares. And so these 3 records are separately uploaded to one node each of SecretVault. And that's how the data is stored. So to put all of that together, the full flow of using SecretVault is to create either an AI agent or an app. So that's down here. That AI agent or app takes in data. So imagine if you had an agent, you're prompting the user to tell you their name and how long they've been in Web3, and also the rating of the product. So they give you all that information, and then the agent says, okay, I will encrypt those fields. So the agent encrypts the private data fields with the NilQL library. That results in the 3 different encrypted records. And then each of those records is uploaded to a separate Nil DB node. And then when you need to decrypt the data or read it, the agent can call the nodes give the pieces of the data, and then you can recombine the 3 pieces to decrypt the data, again with NilQL. And that all happens in a really easy flow through the wrappers. Okay, so now let's actually speed run this flow. So by speed run, I mean we're going to go through the Quickstart really fast. Oh, I can hear somebody. Does somebody have a question? Okay, cool. So we're going to go through the Quickstart really fast. You can code along with me if you want. But if you miss anything, you can send a message in Partner Nillion on Discord, and I'll look at it afterwards. Or just let me know if anything's unclear and I can stop and address the question. But I'm just going to run through the Quickstart straight on my machine. Okay. There we go. So I'm just going to go to docs.nillion.com/quickstart. And you can see there's different things that you can start building. So I'm going to click the SecretVault Quickstart because I want to run through this one. So in this Quickstart, it'll take a little bit about 15 minutes, and we're going to build a privacy-preserving data collection for a Web3 experience survey. So within that survey, we're going to have the name and years in Web3 properties, which we will encrypt, and then we'll leave these experience ratings out. We'll just store them in plain text so that anyone can read them if they wanted to. And this is going to be a Node.js project that I create completely from scratch, as it says in the Quickstart. So let's start building the project. I'm just going to minimize this, and I'll keep this on the left side of my screen. And then I have a terminal over here that I'll leave on the right, and I'll also pull up a code editor. So the first thing that we need to do is create a directory for our project. So I'm going to make a directory and I'll cd into that directory. Next, we need to initialize the project. So it's going to be initialized as a module. So I'll npm init es6, and that will just set the type as module inside of the package JSON. The next thing I have to do is install the SV wrappers package. This is the package that manages secret keys and all of the, wrappers. So this is the package that manages all of the keys and also creates JWT API tokens based on your organization config for Secret Vault. So I have all of that, and I'm just going to open up Cursor. Since this is agentic, I'm going to use a agent-powered code editor for my project. And I'll just open the terminal at the bottom so that I can do everything within Cursor. Okay, so we've set up the project. The next thing I need to do is create a file that will hold my organization config. So now I have this org config file. Within the Quickstart, I have a demo organization config that I'll copy into org config. And now let's quickly talk about the org config. So if you are creating an entity to use Secret Vault, you'll create an organization. I'm just using the demo organization from the Quickstart, but you can actually register your own organization, and I recommend that you do this for your projects here in the portal. So you would just use this registration portal. You could start a new organization. You'd enter whatever you want the name to be and select nodes. These are the 3 demo nodes that will be selected for you, and these are actually the nodes that my organization is using as well. So I'm skipping that step because I already have my organization credentials, but along with the organization credentials, I have the node config. The node config contains the URLs and the decentralized identifiers for each of the nodes. And the nodes are what I will be uploading my data to. Each of these nodes will get a different piece of that data, which is why it's important to have the node information inside of the node config, along with the organization. So the organization's secret key is actually what is generating API tokens for each of these nodes, so that inside of Secret Vault, you know that the organization is the correct person or the correct entity that's writing to the Secret Vault data store. Okay, so we've got our org credentials. The next thing we need to do is actually create a collection schema. So I'll create a file for that, schema.json. This is empty for now, but I'm going to copy the Web3 experience schema into the schema.json. And now we can take a look. So all of the schemas for Secret Vault follow the draft 7 JSON schema schema. And within that, you can add a title for your schema, and then you start to define the shape of the data that you'll be uploading into Secret Vault. If you've ever used something like MongoDB, it's very similar to that, where you set all of the properties that you expect to be uploading. So the first thing I'm expecting is an ID. This will always be set for every record. And then I will be uploading a person's name, the number of years they've been in Web3, and then a collection of responses to questions. So each question will have a question number. So like question number 1, question number 2. And the answer to the question will be a rating between 1 and 5. So for my survey that I'm building, I want people to be able to rate their experience, their user experience with different things. So I'm asking them to rate their experience with Solidity, with the UX of wallets, things like that, so that I can get a general understanding of how the UX is improving in Web3 this year. Okay, so previously we were talking about how Secret Vault is really cool because you can have secret data inside of the vault. And the way that you mark data inside of the schema to be secret is with share. So if something is a share, it's not the actual name. We're uploading the share of the name. So that is that string. If I go back to my presentation, oops. So if this is the original record, The share is the piece of the encrypted data that's going into the node. And so anything that's going to be encrypted, we're marking with the share, and the type of a share is a string. So you can see that both name and years in Web3 are shares, while the array of responses, the properties are just in plain text. So they're integers, strings, dates, whatever is going into that response array doesn't need to be encrypted. So there's no shares there. Okay, so that's our schema. And in order to start uploading data to the collection, we actually have to first upload the schema to all 3 nodes. So in order to do that, I'm going to create a mini script that will take this schema and actually upload it. So I've created a file, and within this file, I'll just paste in the script, and I'll explain what it's doing. Okay, so this is the script for posting a schema to all of the different nodes. At the top, you can see I'm importing the SecretVault wrappers. That's just the collection that helps do all of the API calls. I'm also importing org config. The org config is what we previously created that has the keys and the identities of all of the nodes so that we know where to upload the schema to. So now that I have all of that, I can run this to create a wrapper and initialize an organization. The org has been initialized with those nodes and also the credentials. And in order to actually create a schema, I have to give the wrapper the schema file, which is the schema.json, and the collection name, which in this case is Web3 Experience Survey. This can be anything you want. It's just so that if you're looking at all your schemas, you can easily understand, oh, that's my experience survey. So after that, you can create the schema and it should upload to all 3 nodes. But let's actually test this out. So I'm just going to run node post schema, which is this file. Awesome. So this was successful and it created a new collection schema for all 3 nodes. So this node, and this node. And you'll also see that the ID of the schema is the same for all 3 nodes. And that's really important because you want to be able to write to the same schema and not have to worry about like, oh, did I use a different ID for one node from the other node? It should all be very consistent so that the only difference between nodes is the encrypted share value. And that's because those need to be different so that when you recombine them, you get the true value. All right. So now we have schemas across all of the different nodes. The next thing we're going to do is create a script to actually interact with the SecretVault data. So that's writing data to our schema collection and then reading data from the schema collection. So let's create one more script, which is index.js. And inside of this script, I'll copy in some things. So the first thing is importing dependencies. We actually don't need the UUID package, so I'm going to leave that out. Oh, the AI is trying to autocomplete for me. I don't want this. Okay, so we're going to import the wrappers package, the same one we did before, and also the org config. The next thing we need to do is create a const for the schema ID, and we can read this straight from the console log of the other script. This is going to be hard-coded to the schema we just uploaded to SecretVault. After that, we'll create a data payload. And this will just be, oops, this will just be some data that we want to post to the schema. So remember that each of the encrypted fields are marked with a lot ahead of time to show that these will be encrypted. And then once they're uploaded to SecretVault, they'll have transformed into shares. So instead of Vitalik, let's say Satoshi Nakamoto, he's probably been in Web3 longer than anyone, maybe 16 years. And I'll just leave his responses to the survey as is. So now we have a data payload and we just have to add the main function. Let's run through this main function quickly. So inside of the main function, the first thing we're doing is initializing a collection using the org config nodes and credentials, and also the schema ID that we hard-coded above here. So now we've initialized a collection for this schema. When we have the collection ready, we can start writing data to the nodes. So this collection function, write to nodes, is coming from that wrappers package, and it's just going to write that data to all 3 nodes in the collection. And then it will log out the new IDs. I'm just going to comment this second part out for now, because after we write the data, we can read the data, but I just want us to focus on writing the data to this collection first, and then we'll read the data. Okay, so we have the function and we can run node index.js. This writes data to all 3 of those nodes. So you can see on node 1, it's created this ID. On node 2, it's created the same ID, and on node 3, it's created the same ID. So you can see that it's uploaded this ID to all 3 of those nodes. So the data is successfully in all 3 nodes in the collection. Now let's try reading the data. So I'll comment this out, and we'll just read the data from the collection. I'm going to remove the slice because we didn't actually upload any data right now. So this is just saying, okay, take the collection, read from all 3 nodes. And the reason that this bracket is empty is because we're not actually passing in a filter. If you wanted to, you could filter for different things in plain text. Like maybe you would want to filter for a specific rating to a response. You could do that by passing in a valid filter here. But I'm just going to read the records that are currently inside of the secret vault. Okay, so we see one record. This is that most recent record. That's just Satoshi Nakamoto. Let's add one more record and then we'll write and read. So maybe this can be Jacob from ETH Global. Famous. I have a feeling he's been in Web3 for like, I'm going to say 10 years. We'll have to ask him afterwards. And we'll say that he gives both questions a 5 because he finds the UX awesome. So going back down, I'm going to comment all of this code back in so that it will read, or excuse me, it'll write Jacob's record to our data collection, and then it'll read all of the decrypted collection data. So we should see both Satoshi's and Jacob's record inside of the logs. So coming up here, the first thing that happened is this wrote to the secret vault. So it created one new record, 39F, blah, blah, blah. And then when it needs to read, it reads both records that are inside of the secret vault. So the first record down here is Satoshi, which was previously uploaded. And then we can also see Jacob, which was just uploaded. So you can see that with Secret Vault, we were able to encrypt and write data and then read all of the data back because we have that organization secret key that's needed to read and write from Secret Vault and also create new schemas. So that's a little bit on Secret Vault. I think we just speed ran all of the Quickstart in, I want to say, less than 10 minutes. So I think this should give you enough to use Secret Vault in pretty much any flow that you're doing for your AI agents. If you wanted to do this from scratch yourself, you would just go register a new organization. So you would get your own secret keys for your organization. And then you could start creating collection schemas based on whatever data you want your agent to read and write inside of Secret Vault. So that could be user data. Maybe it's shared state between agents so that they know parts of what each other are doing. Maybe it's memory so that if you're creating context for an agent, they have tons of different things to draw from. Anything like that would be an awesome application for using Nillion SecretVault. And oh, one more thing to mention is that if you come and visit us in Discord, we have office hours every single day, twice a day. So one of the office hours is at, I believe it's 10 a.m. European time, and the other office hour is at 10 a.m. PST. So whatever your time zone is, you should probably have at least one office hour every weekday that will work for you. And we would love to hear what you're building and also help if you have any questions. We're really excited to see what you all build.